about reality often hides in the most absurd things. In the microcosm of subatomic physics, where ordinary laws seem to bend, we encounter a core paradox. Particles that do not exist may be the key to decoding the deep nature of reality. The story of virtual particles is a vivid demonstration that sometimes mathematical tools have a prophetic power far beyond what our senses and direct measuring devices can grasp. Modern physics is built on the foundation of fundamental interactions. Everything we observe, from sunlight to the force holding atoms together, is governed by four fundamental forces: gravity, electromagnetic force, strong nuclear force, and weak nuclear force. However, describing how these forces actually act across empty space has always been a philosophical and mathematical challenge. How can an electron here know and react to the presence of another electron there if there is nothing in between? In classical physics, people were satisfied with the concept of a force field. But quantum mechanics, with its discrete and random nature, demands a more subtle mechanism. It is here that virtual particles enter the stage, not as real actors but as a clever trick. A skillful mathematical tool invented by the great physicist Richard Feynman. Their purpose is to unlock the most puzzling mysteries in the inner workings of subatomic particles. Real particles, meaning particles that can be detected, have definite energy and momentum, and can leave clear traces in measuring devices. Are defined by their observability. They are measurable lumps of energy. In contrast, virtual particles, as their name suggests, are not real in that literal sense. They cannot be seen or directly detected by appropriate experimental instruments. This is a complex computational tool. Feynman envisioned an ingenious accounting system to replace the direct calculation of forces. Instead of trying to calculate the strength of the electromagnetic force between two electrons, physicists use a locality system where this force is carried by extremely short-lived virtual particles. In this visualization, the repulsive force between two electrons is described as a continuous exchange of virtual photons, the carriers of the electromagnetic. This is not just a mathematical simplification. It is a way to solve the persistent problem of action at a distance by introducing an intermediary mechanism, albeit a fictional one. The secret that allows virtual particles to play the role of force carriers lies in the characteristic and strange property of the subatomic world: natural ambiguity. At the heart of quantum physics is the Heisenberg uncertainty principle, most famous for relating position and momentum. However, this principle also applies to energy and time. It is this natural fuzziness in energy balance that masks the transient energy imbalance created by virtual particles, allowing them to exist and influence the real world. Virtual particles exploit this ambiguity to pop into and out of existence instantaneously, transferring force from one real particle to another. They are short-term borrowers of energy from the quantum vacuum. Their moments of birth and death are so brief that they can never be considered observable real particles. But during that fleeting moment, they perform their task of force exchange. The great advantage of this tool is its ability to visualize the mathematics describing the force between particles. These are Feynman diagrams, simple, cartoon-like pictures of particles playing ping-pong with virtual particles. These diagrams provide an excellent intuitive framework, but at the same time, they give virtual particles a misleading aura of reality. However, the miracle lies in the fact that this calculation method based on virtual particles yields some of the most accurate predictions in all of science. Despite their fictional classification, calculations using virtual particles predict the strange behavior of subatomic particles with astonishing accuracy. Supersensitive experiments have confirmed many of these subtle effects with accuracy up to 12 decimal places. To visualize, such accuracy is equivalent to measuring the distance from the North Pole to the South Pole with an error smaller than the width of a human hair. The extremely high agreement between these measurements and calculations forces some physicists to question whether a mathematical tool can become reality. The reality is that all matter we know is made of fundamental building blocks called atoms, with a positively charged proton nucleus and negatively charged electrons orbiting around it. In physics experiments, such as measuring the size of a proton by bombarding a hydrogen atom with a beam of electrons, scientists rely on the idea that electrons and protons interact through the exchange of virtual particles, specifically virtual photons. Calculating the magnitude of the repulsive force between two electrons, or an electron's perception of a proton, is based on accumulating the effects of virtual photon exchange. Another classic physical example is the Casimir effect. When two metal plates are placed close together in a perfect vacuum, they attract each other. This attractive force can be accurately calculated using virtual particle mathematics. In this understanding, this attractive force is caused by an imbalance in the pressure of virtual particles, namely virtual photons, popping into and out of existence in the space between the plates and the space outside. Whether virtual particles are truly there or not, the mathematics accurately predicts what researchers observe in the real world. Even more, the virtual particle tool yields another mysterious prediction related to the strangest objects in the universe, black holes. That is Hawking radiation. The theory suggests that at the event horizon of a black hole, pairs of virtual particles continuously pop out of the vacuum. Sometimes one of the virtual particle partners is swallowed by the black hole's gravity while the other escapes. This permanent separation causes the black hole to lose energy, or in other words, to evaporate slowly. Although Hawking radiation has not been directly observed, researchers have indirectly observed similar phenomena in the laboratory. Returning to the core question, if you can perfectly predict everything about a force by imagining it is carried by virtual particles, do these particles qualify as real? Does their fictional status still matter? The physics community remains deeply divided by this question. Famous phrase. For them, as long as virtual particles remain the best tool for describing particle behavior, their purpose is fulfilled. Others pose deeper philosophical and physical questions. If a model describes reality perfectly, is the model itself reality? T-Real is based on researchers developing alternative approaches that dawn. These approaches, if successful, can make virtual particles vanish permanently from fundamental calculations. The existence of alternatives, though incomplete, suggests virtual particles may be a useful fiction rather than an inviolable physical truth. This aligns with patterns from past scientific revolutions. A prime example is the ether. Physicists once invented the ether as an invisible medium for light waves to travel through. Experiments fit perfectly with calculations using the ether, but no one ever actually detected it. Ultimately, Einstein's theory of relativity proved the ether unnecessary. It was merely a temporary mathematical tool until a deeper theory was found. Virtual particles represent a profound paradox of modern physics. They shouldn't exist, yet are indispensable for calculating everything from magnet strength to black hole behavior. They testify to a truth. Sometimes the deepest insights into reality come through carefully constructed illusions. Ultimately, the confusion about the nature of virtual particles may be the price to pay for understanding the fundamental forces governing the universe. A reminder that the physical world doesn't. May not be the eyes, but reason armed with the infinite power of mathematics. Our quest for truth, therefore, is a journey of constantly questioning what is real and unreal in the flow of knowledge. Subscribe to the channel Beyond the Veil 0707 for the latest videos.